Hey guys, so today we are going to talk about plate tectonics and we're going to finish the page of notes. So yesterday you should have gotten to like the midline of the notes. I think yours look a little different than this. Today we're going to go on some more with the notes. So plate tectonics tells us how the plates drifted. Yesterday we talked about Pangea and we said that the continents did drift apart. So today we're going to talk about plate tectonics. We're going to talk about exactly how those continents drifted apart. So we have what's called a mid-ocean ridge system. If you look at your slide, it's right down here in the bottom. So this mid-ocean ridge system was discovered in the 1960s, and it's a chain of volcanic submarine mountains that encircle the globe. They're the largest geological feature on the planet, and at regular intervals, it is displaced by cracks in the Earth's crust. So if you look, you can see these red ridges that go through the Earth. This is where these mid-ocean ridges are. And they're mountains that are built by volcanoes, kind of like Hawaii. If you think about Hawaii, it's an underwater volcano. So this mid-ocean ridge is where these two plates meet. The magma comes up from the ground into the water, and the water is cool. So this hot magma cools and hardens and becomes new land. So that is what leads to continental drift. The seafloor. At the ridges, huge pieces of crust are separating and causing rifts or cracks in the crust. It releases some of the pressure in the mantle and the core pushes up. So if you think about a soda bottle, when you shake it up and then when you undo the top of the soda bottle, it releases the pressure. So where those two plates are meeting, as the magma comes up, it comes up through that mid-ocean ridge and that pressure is released. As it reaches the surface, it cools and hardens. And the process repeats over and over and over again. So the pressure builds and builds and builds and builds, and then it releases, and it separates it a little more. And then it builds and builds and builds and builds, and then it releases, and it separates a little more. So the process itself is called seafloor spreading, and the ridges are sometimes called spreading centers. So here are some pictures to help you out with that image. So here's your mid-ocean ridge system. Here are all of the ridges as the years have gone on and they've been pushed backwards. So your magma comes up from the inside of the earth. It reaches this cool water. It hardens. And then the next set of magma is going to come up. The pressure is going to build and build. The magma is going to come up. It's going to break apart what was there and push it to the side. And new magma is going to be at the surface now, and it's going to harden. And the process is going to keep repeating. The same thing is going on in this picture. It kind of gives you a better view. You've got Africa and South America. You've got your mid-Atlantic ridge, and you've got your seafloor spreading. And as you move apart, you get older and oldest. And the newest Earth is at the very center of that mid-ocean ridge. So the Earth's surface is covered by what's called the lithosphere. It's a rigid layer. It's composed of the crust and the uppermost mantle. It's 60 miles thick. It's broken into plates called lithospheric plates, and the plates float on top of the mantle. The mid-ocean ridges are at the edges of the plates. So if a plate includes a continental crust, the crust moves along with the plate. So if you live on a continent and your plate is moving, you are moving. Your continent is moving. And this is how the continent separated apart. This is how Pangea was once whole, and now we're in a lot of little pieces. It's this plate tectonic spreading. So if the continents keep spreading apart, why doesn't the globe grow bigger and bigger and bigger? Because I just told you that we're constantly creating new Earth, and these plates are floating on the magma, and they're constantly being pushed apart as new Earth is made. So how come the globe doesn't get bigger? Well, it's because the lithosphere also destroys itself. So there are places in the ocean which are called mid-ocean ridges, and then you have what's called a trench. A trench is a boundary between two plates, and it's formed when the two plates collide and one dips below the other one, and we call that process subduction. So the two plates collide against each other. One plate, the plate with the ocean on it, is going to slide beneath the plate with the land on it. But as it sinks, it begins to build up pressure. And that movement produced as it starts to break up is an earthquake. And as these earthquakes happen and as this subduction zone starts to happen, you're going to start to get more and more earthquakes. This earth down here is starting to break up. So as it starts to break up, it's going to turn into molten material, and it's going to rise back up to the surface, and it's going to become volcanoes. Hawaii. So the rest continues to sink, and it can be reused. In millions and millions of years, all of this that doesn't go back up to this volcano can go down. It's going to be reused in millions of years, and it's going to come back up at a mid-ocean trench again somewhere else. So while the ocean is also growing and moving, we learned yesterday it's 2 centimeters a year. So while it's moving 2 centimeters a year, it's also destroying itself and reusing itself. So it's a reusable material, kind of like when we think about carbon and nitrogen and we have those cycles. It's the same thing. It's a cycle. And that is the end of today's lecture. At this point, turn off the lecture. You're going to watch a video of an activity we're doing in class, and you're going to answer some questions on it.